Good afternoon, everybody. Once again, my name is Matt Roberts, and today I have the great honor of introducing our keynote speaker. Dr. Rebecca Dell is the Senior Director of the Industry Team at the ClimateWorks Foundation. She holds a PhD in climate science from MIT, and she previously worked for the Department of Energy as a special advisor for energy policy under the Obama administration. Rebecca and the team at ClimateWorks Foundation focus on projects that enable the decarbonization of the industrial sector, focusing on reducing the environmental impacts associated with producing the materials and products that we use throughout our daily lives. Rebecca was recently interviewed by PBS NewsHour, where she focused and discussed the White House's pledge to provide $6 billion in support to decarbonize the energy and transportation sectors. It has been absolutely incredible to have Rebecca and the rest of the team at ClimateWorks support as we develop our research area in life cycle assessment and embodied carbon research. And we've engaged in several conversations where Rebecca has pushed us to tackle some of the most challenging questions that our sector is facing today. So it's absolutely incredible to have Rebecca here with us today, and we're really excited to have our talk. So please join me in welcoming Dr. Rebecca Dell.
Thanks, Matt. Hi, everyone. Can you hear me? Great. Well, thank you very much for the very kind introduction, Matt. As I was thinking about what I should talk about here today, I thought, first of all, well, it's immediately after lunch, so probably best not to drown people in facts and figures. Let's keep it loose, keep it high level. And you all are professionals in one way or another from the buildings industry, who I think probably an important motivation for why you showed up in this room is that you spend a significant amount of time thinking about climate. And I thought it might be interesting for you all to hear a little bit about how a climate person like me, who spends a significant amount of time thinking about the buildings industry, how we see, you look at us, how do we look at you? And I think there's two pieces of my background that kind of help me talk about this a little bit. One is my background as a climate scientist, and the other is my background in policy and politics. And so those are the two things that I want to talk about here today. So first, as a climate person, you always start in the same place, which is where do the greenhouse gas emissions come from? As you guys probably know, global greenhouse gas emissions are the equivalent of about 60 billion tons a year of CO2. That equivalent weasel language is in there because CO2 is not the only greenhouse gas. We have a bunch of other greenhouse gases and some methodologies for trying to equate the bunch, but 60 billion tons a year that's the number we're working with. So I'm going to guess probably many of you have heard the statistic that the single largest volume product that humans produce on Earth is concrete. And I hope you are reassessing that right now, because we actually produce much more CO2 than concrete. We just don't have to look at it. So of that 60 billion tons, where does it go? Where does it come from? And well, actually, we know where it goes. Where does it come from? Mostly it comes from two types of things, which can be roughly described as food and fuel. So most of the sectors that emit a lot of greenhouse gases, they do it because they burn a lot of fuels. So that's the electricity sector, the transportation sector, also conspicuously the building sector. And then in addition to that, we have the agriculture sector, which is producing food instead of fuel. But is with it huge amounts of greenhouse gases, about 25% of all the greenhouse gases. So mostly what we're talking about, 3/4 of the greenhouse gases, food and fuel. Well, that still leaves 1/4. And that 1/4 is what I work on. That 1/4 is, it's not food, it's not fuel, it's stuff. It has a lot of names: the material economy, the industrial sector, whatever you want to call it, it's the stuff as opposed to the things we're burning or eating. And so that and producing, what we're talking about here is mining, manufacturing, construction, waste processing, like making, moving around, organizing, and then disposing of our stuff. That's about 1/4 of emissions. And so that's the piece that I want to talk about because that's the piece that I work on. And that's the piece that I think is probably, in the end, most relevant to this audience. And most of the greenhouse gas emissions that come from making stuff, like you can imagine, I just listed quite a lot of different types of things that are behind those greenhouse gas emissions. And inside of every single one of those categories, there's lots of other things. So we're talking about, in the end, like millions of different types of human endeavor that are combining in every type of construction, every type of manufacturing, that's all producing these greenhouse gas emissions. You might think like it's too complicated, I can't deal with it. But it turns out almost all of those greenhouse gas emissions come from a remarkably short list of activities. And they're all activities of the same kind, which are what we call primary commodity processing. So basically, the materials industries, the cement industry, the steel industry, the fertilizer industry, the plastic industry, the pulp and paper industry, the aluminum industry, et cetera, et cetera. All of these industries have the same basic structure, which is that you start with a raw material, almost always something that you dug out of the ground. And then the very first thing you do with that is where all the greenhouse gas emissions come out. So it's that first step in the supply chain that turns a rock or a tree or some crude oil into a useful industrial material. That's where that is the activity of climate interest. Why is that? Why is it only the material industries that dominate? And 2 reasons. Reason number 1, these materials are the ingredients that we use to make everything else. And since everything else is made out of this relatively small, relatively short list of materials, we produce these materials in larger quantities than anything else. We produce steel and cement in increments of billions of tons per year. We produce plastics in increments of hundreds of millions of tons per year. We produce forest products and aluminum in increments of tens of millions of tons per year. So like these are the only products that get produced at this scale. So obviously like big scale of production, big scale of emissions. But there's actually a second and more important reason, which is that you have to do a lot of chemistry at this stage, and that it takes a ton of energy, and often it creates greenhouse gases in addition to the energy consumption. And let me give you just one example of that, which is the most important one from the steel industry. How do we make steel? Where does steel come from? So the way we make steel is you start with iron ore, which is any one of a variety of different kinds of iron oxides, which is to say iron atoms chemically bonded to oxygen atoms. So you guys are probably more familiar with iron oxide by its common name, which is rust. And we all know that, like beautiful patinas of a nice piece of core 10 to the contrary notwithstanding, rust does not have the valuable material properties that steel has. So the central activity of the steel industry is basically to break the chemical bond between the iron and the oxygen. That's the thing that you have to do. And breaking that chemical bond takes an enormous amount of energy. If you have a piece of steel, of solid steel, and you want to melt it, people think of that as like a high energy activity. You do have to cook it at like 1,700 Celsius, so like 2,600 C, if you want to melt it for most steels. So it seems like energy intensive, but actually it takes almost 10 times that much energy to do that chemical reaction where you break where you separate the oxygen and the iron. And how do we do that? Well, in almost every facility, almost everywhere in the world, the way that we do that is that we provide those oxygen atoms with something that is more attractive for them to bond with than the iron, namely carbon. We put in carbon in the form of coal, and we say, hey, oxygen atoms, come over here. This is a lower energy, more relaxed place for you to hang out. And so we get metallic iron out, and we get typically more than 2 tons of CO2 for every ton of steel that we produce. So that's a problem. But this goes back. So that's why, kind of in a big picture, why are we talking about, when we talk about the greenhouse gas emissions from the industrial or material economy, why are we always so focused on this short list of materials? It's because, one, we're producing them in billions of tons or hundreds of millions of tons a year. And two, we have to do all of this chemistry at this stage that requires so much more energy, generates its own greenhouse gas emissions. And as a consequence, it makes sense, right? If you have to actually do a chemical reaction to make a new material, that's going to be harder than if you have a material and you just need to put it in a new shape or combine it with other materials. So we focus on the materials industries, and you can see this very much in the overall greenhouse gas statistics. So I mentioned to you that 25% of all the greenhouse gas emissions from the industrial sector came from the material economy. Of that 25%, approximately 3/4 comes, or approximately 2/3 comes from just 3 industries: steel, cement, and chemicals. So the big 3, as I refer to them, just those 3 industries are 20% of all greenhouse gas emissions from all sources. So you probably are like, well, this seems sort of moderately interesting, but why are we here? Why are you here? What are we talking about? And here comes the kicker. Of those 3 industries, fully a half of those materials are going into the built environment. So from a greenhouse gas emissions perspective, basically half of the direct emissions from the industrial sector are for making materials that go into the stuff that all of y'all build. So you have a huge amount of leverage here, because you're the ones who are you're buying the stuff, or in some cases you're making the stuff. So that's how the construction industry looks to somebody who comes at this from from a perspective of strict climate logic. We need to focus on the construction industry because you guys are because the stuff that y'all are using adds up to 12% of all the greenhouse gas emissions, which is just a crazy amount. So what does that look like? That's basically all the cement emissions. That's between 55 and 60% of the steel, and that's 1/4 of the chemicals. And those chemicals. So the chemical industry is a fun one. What is the chemical industry? It's a great question. But in the case of the buildings industry, mostly what we're talking about here is all of the plastic-based products that are used for things basically almost anything in a building that's not made out of wood, metal, glass, or concrete is a product of the chemicals industry. Oh, thank you. That's so kind of you. All right. So here we go. I've kind of broken it down for you of where do the from at the highest level, where do the emissions come from? Why does this matter so much? So then let's talk a little bit about what we're going to do about it. And I want to talk about that in 2 different ways. I want to talk about that from a technical perspective, and I want to talk about that from a public policy perspective. So on the technical side, what can we do? Basically, all of these industries right now are driven by fossil fuels. They're overwhelmingly dominated by fossil fuels, both for their energy inputs, for their fuels, and also for their feedstocks and their chemical reactants. So in order to change that, or in order to reduce our emissions, there's like 5 basic options that exist theoretically. Not all of these options are practical options in all cases. In fact, most of them are not, are highly impractical in most cases. But your 5 basic theoretical options here for reducing emissions from a material industry are: 1, you can just use less of this material. That's a very important one. We're going to come back to that one. 2, you can do something called carbon capture and storage. So you guys may or may not be familiar with this. Basically, the idea is that you keep doing you keep doing whatever it is you're doing. Fundamentally, you don't change what you're doing. But then you put some very expensive equipment on your facility that will take the CO2 and separate it out from the other waste gases. And then you take the CO2 and you put it in a pipe, and then you put the pipe into a hole, and then you pump the CO2 under the ground. And you can think of this as like a great circle of life. You know, we dug the carbon out of the ground. Now we're going to put the carbon back under the ground. You can like the way that I think about it is there's like dumb carbon capture, which is just like you can take any pipe in the world that has CO2 in it. You can put some scrubbers on it. You can pump it underground. You can do that anywhere. It might be very expensive. There might be better ways to do it, but that's always an option. So use less, carbon capture and storage. Then we have some of the like sexier options. So sexy option number 1 is hydrogen. For any of you who work in the energy sector at all, you may in the last couple of years have gotten the vibe that like, whatever your question is, hydrogen is the answer. Hydrogen can be useful in many instances. The thing about hydrogen, though, is that it's not an energy source. It's an energy carrier. So you have to make the hydrogen out of something. So you can start with a fossil fuel and you can turn that into hydrogen, in which case you may have some other problems you still have to solve. You can start with water and you can separate out the hydrogen and the oxygen in water and you can make hydrogen. But then that took a lot of energy. Where did that energy come from? Did it come from burning fossil fuels? All good questions. So hydrogen, it's a real thing. It's a real option. But let's say there's some nuances there. Then option number 4, biomass. It turns out carbon is this fantastic molecule or this fantastic element. You can do anything with carbon. How about we just don't dig the carbon out of the ground? We get it from plants. Again, that's a great option. You can use it in lots of circumstances. The problem is that the industries that I listed for you, steel, cement, chemicals, just those 3 industries, their total energy demand, actually, crap, I didn't prepare this, so I'm going to have to do some math in my head. So the chemicals industry uses about 55 exajoules of energy a year. The steel industry uses about 30 exajoules of energy a year. The cement industry uses about 15. So I think we got up to 100 exajoules there. Check my math. Anyway, so just these 3 industries use 100 exajoules of energy a year. That's probably not a meaningful number to most of the people in this room. Most of you are probably thinking, what's an exajoule? Doesn't matter. Here's what matters, is that the total amount of bioenergy that we currently have on Earth in all energy systems is like 60 exajoules. So bioenergy could work great. It's not going to work everywhere. So returning to our buckets, remember we had use less, carbon capture and storage, hydrogen, biomass, and the last one, which is the favorite of like technophilic Silicon Valley people across Northern California, is direct electrification. Can we just, whatever the thing is that we're doing that we're currently putting fossil fuels into, can we put electricity into it instead? So those are our options. In all cases, we are limited to those options. And generally, as my kind of my somewhat rambling commentary going through this list would indicate our basic problem is carbon capture and storage, often very expensive. Hydrogen, well, the hydrogen's got to come from somewhere. That requires a lot of energy to make the hydrogen in the first place. And oh, I forgot to mention hydrogen's also a greenhouse gas itself, and it likes to leak out of things. So hydrogen's got its own problems. Biomass, great if you can get it, but you're not going to be able to get enough. And direct electrification, our basic problem there is that in almost every instance, you have to invent a new factory. So we're going to use some combination of all of these. But the only one of these that doesn't have like a huge asterisk next to it is the first one, is use less. And that's where you all come in, because there are huge opportunities to reduce the total amount of materials, or maybe not reduce the total amount of materials, but reduce the total amount of the most greenhouse gas intensive materials in any construction project. So I think this probably gets discussed most in the context of cement, where, as all of you know, there are huge options. There are many, many things that we can do to reduce the amount of clinker, the most greenhouse gas intensive ingredient in our cement. We can reduce the amount of clinker in our cement. We can reduce the amount of cement in our concrete. We can reduce the amount of concrete in our structures. We have similar options for steel and for every other construction material as well. Julian Allwood and his group at Cambridge University have done a number of analyses where they have found that for the structures that they, for the buildings, they're all buildings that they analyzed, which were across both Europe and North America, between 35 and 100% more structural material was used than was needed to comply with the extremely safety protective building codes that governed the structure in question. So you guys are probably also familiar with options like with blended cements, like limestone and calcined clay cement, where you can duplicate the compressive strength and many other of the most important properties at lower cost of your cement with about a 30 to 40% reduction in the amount of clinker, or rather a 30 to 45% amount of reduction in the amount of clinker, leading to between a 30 and 40% reduction in the CO2 emissions. So this is an area where you all can make a big impact technically. So I want to finish by talking a little bit about not how do we do this technically, but how do we do this like socially, economically, in terms of government policy and all of that? Like, how do we make this happen? And when in my work in this space, I tend to think about it in terms of kind of like, there's three buckets. So the first bucket is, how do we scale up the things that we already know how to do that we can do right now? The second is, how do we get to zero? And the third, which is the most important because the first two are dependent on it, is how do we create demand for people who are trying to do the first two things? How do we create customers, market structures, policies, all of those things that mean you can make money if you are scaling up good solutions or trying to get to zero? So I just want to give you a couple examples of the types of public policies that we've been working on, and how they fit into this framework, to give you a sense of what is of how we're trying to make this happen. Here in California, we are the beneficiaries of some very forward-leaning environmental politics. I would like to think that not just California is the beneficiary of California's environmental ambitions, but we actually are the only state, and in fact, to my knowledge, the only jurisdiction anywhere in the world that has something like a law that was passed a couple of years ago, which was poetically titled SB 596. Don't ask me, I didn't come up with the name. So SB 596 was a law that was passed through the California state legislature, which said that that all of the cement used in the state of California, either produced or used in the state of California, has to get to net zero emissions by 2045 and has to have a 40% reduction in its CO2 intensity by 2035. And basically, those are targets that are binding in law, which means that the state of California is already working on all three of the pillars, of the strategic pillars that I mentioned. They're already thinking about how do we scale up what we can do right now? How do we get the zeros, the net zero options onto the market? How do we create demand and structures that will sustain this, that will pay for this over time? So that's kind of the overarching policy framework. Now, in terms of how do we scale what we can do right now? Almost all of the scaling that we can do right now fits in the use less category. Is about lower carbon or lower clinker cements, lower cement concretes, more structurally efficient buildings. And there's a few other things that we can put in there. Like, for example, there are relatively small parts of the steel and chemicals industries that are already electrified. And so we could be using renewable electricity for those small parts. Those are like, that's relatively low leverage, doesn't go with the big emissions, but like, it's useful. Sure, let's do it. And so we're doing things like working with Caltrans and also the US Federal Department of Transportation, people who pour an awful lot of concrete, to get their specifications changed so that they are amenable to using these alternative cements and concretes. This is a situation where the people in this room have the opportunity to be very influential, because you may have noticed that the construction industry is a pretty conservative industry. I remember relatively early in my career in industrial decarbonization, having a conversation with a structural engineer who was like he wasn't like a climate denier or anything, but let's just say he was not an enthusiastic member of Team Climate. And I was like talking up all of these cool alternative cements. And he said to me, he was like, how about this? How about you build your bridge out of those cements, out of one of those cements, and then come back in 40 years. We'll go take a look at it, and I'll tell you what I think. So this is not a great attitude, but it's also, I don't think, it's not a rare attitude. And so when we think about trying to move the big purchasers, like the infrastructure, agencies of governments, like the very large construction companies, those types of things, essential to being able to move them to even to the technologies that are available right now, is being able to point to projects in the real world and say, look, we did this lower carbon alternative in this project and it worked great, and it looks beautiful. So fear not, this will be great. And when we think about going to regulators like the California Air Resources Board, like the US EPA, like other leading regulators around the world, they will always tell you, we cannot regulate, we cannot require a thing that doesn't exist. The most ambitious regulation we can pass is the best performance that's currently on the market. And so we need examples that we can point to that says, we have set the bar very, very high in these projects. And so you can feel confident setting a regulation or setting a specification that matches this level of ambition. So that's what we're doing. So that's the kind of approach that we think about from the perspective of what can, scale the options that we have right now. However, So we talked a lot about using less, material efficiency. That's great. We all know you can't efficiency your way to zero. So then we need a separate work stream, which is how do we get to zero? And that's this conversation that I was describing with the CCS, the biomass, the hydrogen, the electricity, some combination of those, figuring out what's best there. Now, Matt mentioned my recent let's just leave it unmodified. My recent appearance on the PBS NewsHour. The reason that the PBS NewsHour was interested in talking about low carbon cement, among other things, was that the US Department of Energy had just announced that they were going to spend $6 billion on 33 projects around the United States that were going to try to get a lot closer to zero than current production in all of these industries. This is incredibly exciting. This is the largest investment of this kind that has ever been made in industrial decarbonization. So 25% of global greenhouse gas emissions, $6 billion is the biggest investment that's been ever made. Don't get me wrong, $6 billion is a lot of money. If I saw $6 billion on the sidewalk, I would lean over and I would pick it up. But that is not a lot of money when you compare it to the trillion-dollar scale of the industries we're trying to transform here. So it's a great start. It's a down payment on future changes. But all of the projects that are being funded with that $6 billion and many other projects beside that companies in these sectors are considering, in many cases, the single most important factor about whether or not this project actually gets built, and if it gets built, the people who own it are actually motivated to operate it at high capacity, is do they have customers? So you all in the construction industry do not necessarily have the same kind of direct access to the efforts to commercialize these new technologies that you have in the efficiency space or in the material efficiency space, but you can be customers for these future green materials. And I want to reassure you that you can definitely afford it, because these materials, while they are, per Matt's presentation this morning, a huge percentage of the total climate impact from the lifetime of a building, they are a negligible amount of the cost of the projects. The total amount of money spent on, this is a relatively easy thing to calculate. You can take the total amount of money spent on cement in the United States by private sector actors. You can divide it by the total amount of money spent on construction in the United States by private sector actors. And what you will find is that the average cost, the average percentage of the cost of a construction project in the United States that is represented by buying the cement is 0.6%. If you don't like that number, don't come at me, come at the US Census. I'll give you the links. Now, it's very, very seldom conceptualized in those terms because you don't actually buy the cement. You contract for concrete of different types to be delivered, or you don't even do that. You contract for a more completed stage of the project. And so the cost of the materials gets lumped in your budgets with a lot of other costs, including a lot of labor costs. But the raw cost of the materials is literally a rounding error in many cases. So signing up through initiatives like Steel Zero and Concrete Zero, or the First Movers Coalition, or just through reaching out to the suppliers in your network and being like, hey, we really want to buy this stuff. Is there a way that we can, express that more forcefully? Particularly if you can get together with other actors in your space and make coordinated asks, this can be extremely powerful in supporting the getting to zero piece. Now, that's the private sector piece. There's also a public sector piece of this, which we call buy clean, which is like, okay, governments, you're buying a lot of construction materials. Can you also buy lower carbon stuff? My understanding is that this is not really an infrastructure group, so I'm not going to spend a ton of time talking about that. But the point is that you guys have a lot of leverage over greenhouse gas emissions globally. There are policy structures and governments and government agencies at multiple levels in the United States who are trying to achieve the same things that you want to achieve. And so there are a lot of opportunities for you guys to make an impact. And with that, I will just thank you all for your time and invite the hardest questions that you can think of. Bring me your worst questions.